In this video, we are going to look at an exam question to do with efficiency and energy. Pause the video now and try all parts of this question. In question 2a, it says calculate the energy input to the power plant to give a daily electrical energy output of 1.3 times 10 to the 11 joules. So we know that the efficiency is 0.24 or 24%. So the efficiency times by the input energy will equal the output energy, which in this case is 1.3 times 10 to the 11 joules. So solve this equation and we end up with 5.4 times 10 to the 11 joules. Part B. Calculate the daily mass of wood chips required if the calorific value of the wood chips is 10.4 megajoules per kilogram. So the calorific value is 10.4 times 10 to the 6 joules per kilogram. And we know that the input is 5.4 times 10 to the 11. So therefore the mass, it should be fairly obvious, is going to be 5.4 times 10 to the 11 joules over 10.4 times 10 to the 6 joules per kilogram. And if it's not obvious, hopefully now you can see from the units that joules cancels. 1 divided by kilograms to the minus 1 equals kilograms. So that obviously gives us our mass, which is 52,100 kilograms. Part C, calculate the maximum theoretical efficiency. So it's when you get this theoretical efficiency, it's a clue that you need to use the efficiency from the engineering section of the course. So here, the efficiency, which often is given by this eta symbol, is T hot minus T cold over T hot. But we can't just use degrees Celsius. That's not okay. We need to convert to Kelvin. So 420 degrees Celsius in Kelvin is 693 Kelvin, obviously adding 273. And 10 degrees Celsius into Kelvin is going to be 283. So now our efficiency is going to be 693 minus 283 over 693, which is equal to 0.59 or 59%, either is fine. State one reason in practice why the power plant has a lower efficiency than your answer into the previous part. So there's loads of possible answers here, but we need to be specific. We can't just say waste energy. We need to give a part of the machine where energy will be wasted, such as friction in moving parts. Okay, because it's never possible, even with lubrication, to get down to zero friction. We could say very specifically things like I squared are heating losses in wires in the generator. So very clearly saying that the wires are going to heat up because they have some resistance. We could also say things like, more complicated things like, the steam cycle itself is never going to be truly adiabatic or isothermal, which is one of the assumptions we make on PV diagrams. But I'm not going to go into any more detail here because there isn't a graph just to show you, or any other valid reason, but those are the most likely ones. And then part III, one advantage of wood grown for fuel instead of oil or coal. I mean, there's loads of things you could say here. You could say things like the trees can be regrown, okay, so they are, somewhat renewable. You could say they are almost carbon neutral because the trees, when they grow, absorb CO2, although that in itself is a very controversial point. You could also say things like when you burn the wood, you don't produce sulfur dioxide and acid rain, whereas fossil fuels would. So there's loads of possible answers.